Hello everyone, welcome to the lecture series of Theory of Computation. In the last lecture we have learned about what are regular expressions and how to frame regular expressions. In this video we'll practice some more questions of regular expressions. So let's get started. Now let's say if the question is, write a regular expression for all words that contain exactly 2 B's or exactly 3 B's. Right? If this is the question and we have to write the regular expression for this. So let's see first for exactly 2 B's. So it says in the entire expression there has to be exactly 2 B's and they can be at any position. It's nowhere mentioned that they have to be in the beginning or at the end. So let's say we have one B here. In front of it we can have any number of A's since there is no restriction on the number of A's. Then again we have a B. Then again we can have any number of A's. So any kind of string can be formed from this regular expression where the number of B's are exactly 2 in total. Right? And there is no restriction on the number of A's. Similarly for 3 B's, this much part remains same. Now for 3 B's we can add one more B over here and then any number of A's. If we take the common part from here, this is the common part, then here we will be left with lambda and here we will be left with B A star. So this can be one of the regular expressions for exactly 2 B's and exactly 3 B's. Let's come to the next question. Let's say we have to write a regular expression for words with no substring AB. So we have to write a regular expression for all those words that do not contain the substring AB in it, right? So substring AB contain nahi honi chahiye. That means our string or our regular expression should not begin with a A, right? But it can begin with a B. Any number of B's can come, right? Followed by any number of A's. So any kind of string can be formed from this regular expression provided it does not contain the substring AB in it. So substring AB cannot be formed from this regular expression since after A there is no B. If we would have placed a B over here, that would guarantee that the substring AB can be formed, but here no substring AB can be formed from this regular expression. Let's see another part. Regular expression for all words with no substring BBA and no substring ABB, right? So it says write a regular expression for all those words that do not contain the substring BBA in it and do not contain the substring ABB in it. So let's see for first BBA substring. So this substring should not be formed from a regular expression, right? So that means 2 B's together followed by an A, right? So let's say if I start my regular expression with any number of A's, I can do that because there is no restriction on the number of A's. Then let's say if I have a B. Now after this B, I should avoid another B because if I place an A at the end, that would guarantee, like if I frame something like this, then that would guarantee that BBA substring can be formed from this, right? So we have to avoid this B, the second B from here, but single B is accepted, right? So let's have a single B. Now again I can have A, right? I can have any number of A's as well. Now if I do this, then what it would guarantee? I can have any number of A's formed from this. I can have B. I can have BA substring is guaranteed because this BA is mandatory. Then from this A, any number of A's can come, and this pattern, this much pattern, it can repeat in any number of times, right? Because of this star over here. So I can have this, then again I can have BA, A, then I can have BA, BA. So this can repeat any number of times. Now, till this part it's correct. Now, what we have to ensure, we can ensure that after this, any number of B's can follow, right? Because let's say if I have to form a substring like this, AA, BA, any number of B's. If I have to form this kind of substring from my regular expression, obviously this is a valid substring because it is not containing the substring BBA in it, right? So this substring should be, I should be able to form this word from my this regular expression, but till now I am not able to form this. But if I place B star over here, now I can guarantee any number of B's at the end can follow. So now any particular string or any particular word I can form from this regular expression, provided it should not containing the substring BBA in it, right? So we can check that as well. We can have any number of A's, then BA is guaranteed. If I do not take any A's from here, then this BA can repeat any number of times because of this star, followed by any number of B's in the end, right? And if I have to include this A also, then BA, any number of times BA, followed by any number of A's, then any number of BB's at the end. So BA substring will not be formed in any case from this regular expression, and every other word can be formed from this regular expression that is satisfying my language. Now this is for the substring BBA. Now we have to form another regular expression that is not containing ABB substring, right? So from this regular expression, can I form ABB substring? Yes, I can form ABB substring from this. See, here only in this word only ABB substring is present. So this regular expression is definitely not valid for the second part. I have to frame another regular expression that is not containing the substring ABB in it, right? So what we can do? Now it's starting with A, so I can have any number of B's, right? Just the same part that we did for this. I can have any number of B's in the beginning. Let's say I have A. Now any number of A's can follow, right? There can be any number of A's that I can follow from this regular expression, this much part, because till now I am not able to form the substring ABB. Any number of A's, I can have, let's say, 1B, right? Now till this part is correct. Now I have to make sure that another B is not at all placed over here, because that would guarantee ABB substring. So this pattern can repeat, but I can have any number of A's, so I can place an A star. So my regular expression becomes B star, A star, A, B. Again, this does not guarantee that this is the only regular expression for this particular language. As discussed in the last class, for the same language can be represented with number of different regular expressions. So this is one of the regular expressions that we can use to represent such language. I can have any number of B's since there is no restriction on the B. I can have any number of A's over here to make sure that every word is being formed, provided it is not containing ABB substring. Then I can have 1B is allowed over here, right? Now I have to avoid second B from here in any case, right? So this can be repeated any number of times. So I can form, let's say, triple B from this regular expression, any number of A's from A star, AB is guaranteed as it is. Then this much part, this can repeat any number of times because of the star above. Let's say A, AB, 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 and then any number of A's in the end. So my entire regular expression combining the two becomes A star, B, A star, star, B star plus B star, A star, A, B star, A star. So now these two guarantee that it is not containing the substrings BBA and ABB in it. Let's take another example of a language. Let's say I have to frame a regular expression for a language of all words that should have at least one A, and at least one B. So at least 1A and 1B should be present. So since the position is not mentioned, so that can be at any position, let's say A plus B star, any number of A's and B's can follow. This is a mandatory A, then again A plus B star, then a mandatory B, then again A plus B star, right? I can reverse the positions of A and B also to accommodate all those strings that are beginning with a BA. B, A plus B star, A plus B star. So this is one of the regular expressions to frame such language. I can use another regular expression to represent the same language. So let's say if I use only this much part, A plus B star, A plus B star, B, A plus B star, right? Now the only strings that are left in this regular expression are those that are starting with a BA, right? So I can add BA substrings like this, B star, B, A star, right? Or we can reverse a position. This same regular expression can also be written like this also. We can write it like this also, B star, A star, right? So now this regular expression is also valid for the language, that it should contain at least one A or at least one B. So in yesterday's class we have seen that if the same language can be represented by two different regular expressions, we say that the regular expressions are equivalent. So we can basically say that A plus B star, A plus B star, B, A plus B star plus A plus B star, B, A plus B star, A plus B star. This is equivalent to this regular expression A plus B star, A plus B star, B, A plus B star plus B star, A star. So since they are representing the same language, we say that the two regular expressions are equivalent. Now let's say all these languages that we have seen just now, these are all infinite languages, right? There can be many different words that belong to my language. But let's say if I have, so for all these such languages where their language is infinite, we mostly use star to represent such languages. But whenever there is a finite language, this is for infinite language. But whenever there is a plus sign, that will mostly represent a finite language. Not always, but mostly it will represent a finite language. Let's say I have a language of words, a finite set containing only these 4 words in it, right? One of which is lambda. So this language can be represented by a regular expression. Let's say the regular expression can be lambda plus A plus AA plus BB. So this is my regular expression, right? So this is a finite language, so we are using plus sign to represent such language. Now in the last lecture we have seen some rules to identify a regular expression. Now in this, let's identify the language corresponding to those rules that we have seen in the last video. So languages associated with regular expressions, languages associated with the regular expressions. This is a regular expression. So with any regular expression, the languages associated with it, the first rule say that the language associated corresponding to the regular expression lambda is just the lambda this. So this is the language, one word language corresponding to the regular expression lambda. The second rule says if R1 is one of the regular expression, and the language associated with R1 is L1. If R2 is another regular expression and the language associated with R2 is some language, let's say L2, then for the regular expression R1, R2, the language will be concatenation of L1, L2. Similarly, for the regular expression R1 plus R2, the language associated will be L1 plus L2. Similarly, for the language associated with the regular expression R1 star, the language will be L1 star. So this is in terms of the language. In the last video, it was in terms of the regular expression. Now there is one more definition or one of the conclusion which says if L is a finite language. Finite language means that contains only finite number of words in the set. Then L can be defined by a regular expression. So what does it say? That if my language is finite, so for finite language, there will always be a regular expression corresponding to it, right? So for finite languages, just you have to place the plus sign in between, and let's say if this is my one of the words A1, A2, A3, A4. So if these are my words belonging to my language, so this is the regular expression corresponding to that language. So for every finite language, there will always be a regular expression. So basically we can say that all finite languages are regular. So for finite languages, it always guarantees that they will always be regular, but for infinite languages, it does not guarantee that whether it will be regular or not. So that we'll see in subsequent videos, that if the language is infinite, if it is not regular, then that language is what kind of language, that we'll see in subsequent videos. For now, we just have to remember this conclusion which says that if the language is finite, then it can always be represented by a regular expression, and any language that can be represented by a regular expression is a regular language. So which in turn proves that every finite language is a regular language. Now let's see, till now we have seen that if the language is given, how to frame a regular expression for it. Now let's do the reverse part. If the regular expression is given, how to identify a language for it. Let's say if the regular expressions are some of the regular expressions given, such as let's say A plus B star, AA, BB, A plus B star. So what kind of language is this? So we can clearly see that it contains all strings of A's and B's that at some point contain a double letter, right? Either they contain a double A or they contain a double B. So that is mandatory, right? Because there is no star sign above this. So it ultimately guarantees that any string that will be formed from this regular expression will either include double A or include double B. So this is the language, strings of A's and B's that at some point contain a double letter. Let's take another regular expression. If it's given A plus B star, A lambda plus BBB. Now, sometimes if it is difficult to identify the language like this, so we can break it in parts. We can write this as A plus B star, A plus B star, A, BBB, right? So now it's clearly visible that it will contain all strings of A's and B's. From this we can say all strings that are ending in A, right? And from here it guarantees that all strings that are ending with this substring. So this is the language for this particular regular expression. Let's take another regular expression. If the regular expression is A plus BB star whole star. Right. So what does this guarantee? First of all, we will be able to form lambda from this, right? Then we can see that it containing all strings of A's and B's, that are beginning with A, right? It will not contain any string that is beginning with a B. So all strings of A's and B's, first point that it guarantees it, that begin with A only, do not begin with a B. And we can see whenever B appears, it will always appear in twice. Basically, it will appear in clumps of even numbers like 2, 4, 6, 8, right? So, first conclusion is that it begins with A. Second conclusion is B appear in clumps of even length, right? So all such strings are belonging to my language. So this is the language associated with this regular expression. Let's take another question. Suppose we are given with A star, B, B star, followed by whole star. Now again lambda will be part of my string. Then all words in which A's and B's, we can clearly see A followed by this double A, and this double A will come twice only. First double A, then in next we can take it twice, then we can take it thrice, and so on. So basically my number is being formed, that is odd number. And similarly from here also it is forming an odd number of B's, right? So what we can say, first all words that are containing lambda, then second conclusion, both A's and B's occur in odd clumps. One more conclusion we can draw is that it is beginning with A and ending with B only, right? We cannot have such words which are beginning with B or ending in A. So third conclusion that we can draw is begin with A and end in B. So that's it. That are the conclusions that we can draw for this regular expression. Let's take another regular expression. Let's say if we have the same regular expression but just with a slight modification. Whole star, then A star, then B star, whole star. So this is one part, we can say this is another part, right? So first of all lambda will be part. Then again we can see A's and B's will appear in odd clumps. So this is the second conclusion. Odd clumps of A's and B's. Now here we can see the difference. In the previous regular expression, it was mandatory that it will start with A only. But here our strings can start with B also. And if from this particular string, if I take lambda, then my string can start with an A also. So can start with both A and B. Can start with both A or B. But we have to make sure that there would never be a word that is ending with a A. Right? This language will not derive any such word that is ending with an A. It will always end with a B only. Right? So this is another conclusion that we'll draw, that it is ending with B only. Let's take another question now based on this. Let's say if I have again the same regular expression B star, whole star, then A star, then B star, whole star, then A star, whole star. Now three parts in this, one part this, one part this, one part this. Same thing, but again A's and B's appear in clumps of odd length. Lambda will be part of this string, can begin with A or B both. It can begin with B also. If we take lambda from this part, then it can begin with A also. And in the ending part, now it can end with B also if I take lambda from this part, and it can end with A also. So can start with AB, can end with AB, but A and B appear in clumps of odd length. Now let's take, if I take another word as A plus B, A whole star. So what all words will be part of my language? I can have AA, I can have BA. So we can see that the length of my word will always be even, right? One will be chosen from this and combined with this A, so that will ultimately form my words of even length only. So what is the language? All words of even length. But the condition is they will have to end in an A only, they cannot end with a B. Ending with A only. So this is the language. So both ways we can do it. If the regular expression is given, we can frame the language, and if the language is given, we can frame the regular expression. Now this we have already seen. Let's say if I have A star followed by another star over it. So this is equivalent to A star only, right? Any string that can be formed from this can be formed from this as well. Similarly, if I write A star, B star. Now is this A star, B star equivalent to A plus B star? No, it is not equivalent, because here we cannot have A's after this B. But if I place a star above this, now the two regular expressions you can say are equivalent, because any substring or any string that can be formed from this forms all strings of A's and B's, that we have already seen. Any string of A's and B's can be formed from this regular expression, and because of this star above it, we can form any string of A and B from this regular expression as well. Any number of A's from here, any number of B's from here, then because of this star, any number of A's after it. So any number of A's and B's can be formed from this regular expression as well. Let's come to another important language, which is the even language. So even language in theory of computation says that a language of all words that contain an even number of A's and even number of B's. Again, the number of A's and B's can be distributed in any particular order. There is no fixed order that whether the A's will come together or the B's will come together or they will appear in clumps. They can appear in any order across the string, but the condition is that their count should remain even, both for A's and both for B's. So let's see how we will write the regular expression for this. So for this language, even, first I can have double A as part of my language, right? I can have double B as part of my language. So this is fixed, even number of A's from here, even number of B's from here. Now, let's say I can choose either AA or BB. This is also valid. Now, to make sure that the count of A's remain even, if I place something over here in front of this, then I have to make sure that it is balanced with an equivalent string by placing that string over here also, so that the count of A's and B's remain equivalent in any scenario. So if I place, let's say, AB here, right? I can have AB as well here, right? Again, the count of my A's and B's remain even, right? A, 2 A's from here, A. B, 2 B's from here, B. I can have BA also here, right? I have to place BA here also to make sure that the count remains even. So this part is valid. The count of A's and B's is my even. But this is not guaranteeing that it can repeat any number of times. Let's say I have to form a string such as BA, AA, AA, then BB, then AB. So it has 2, 4, 6 A's and 4 B's in it. So how to make sure that this can repeat any number of times? In order to accommodate twice double A together or twice double B together, I can place the star over it, right? Now, in order to make sure that this expression can repeat any number of times, let's say I have to form a string such that I can have BA, then AB, then AA, BB, then AB, BA. Now this particular string that I have formed, or let's take a smaller string to understand this. Let's say if I have to take a string such as I take a string as, let's say, AB, AA, AB. Then again AB, BB, AB. Now how will I form this string from this? To choose AB, I can choose this. Double A can be chosen from this. AB can be chosen from this. Now again I have to form this. So how will I do? I have to place a star above this to make sure that it can repeat any number of times. So basically this opening bracket will come here to make sure that the A's can repeat any number of times. So my entire regular expression for the even language will be AA plus BB plus AB plus BA, AA plus BB star, AB plus BA, and this whole with a star. So this is my even language. Why we are including these two also in our star? Because let's say if I have to form double A followed by AB followed by AA, then BA, right? So because to ensure that my string can start with a double A also or with a double B, and this can repeat any number of times, I have to place a star on the entire regular expression rather than only on this part of the regular expression. So this is the regular expression for the even language. Again, a very important regular expression which will be used later to draw the finite automata. Now let's take a few more examples of languages for which we have to write the regular expression. Let's say if the language is given as write a regular expression for language of all words in which A appears triple, right? So basically A should appear in counts of, let's say, 3 or 6 or 9 or 12 ways. So how we can write it? A appears triple, right? So that means triple A should come together. To make sure it can repeat any number of times, we have to place a star above it. Now there is no restriction on the B. B can come any number of times. So I can place any number of B's here also. I can place any number of B's here also. There is no restriction, right? And the whole can be placed under a star to make sure that it can repeat any number of times. Another way we can write it triple A plus B star. It can repeat any number of times because of this star. So the adjustment of these two can, that is triple A and B star, can be arranged in any particular order. The only thing is that we have to make sure that A appears triple, that is being ensured from this part. Let's take another regular expression, another language. Suppose it says write a regular expression for a language of all strings that end in a double letter. So we know what's a double letter. Double letter is double A or double B. So all strings that end in a double letter, that means either they end in double A or they end in double B. But before it, any number of A's and B's can come. So we can simply frame the regular expression like this, right? Let's say if we have the other way around, if it says write a regular expression for all words that do not end in a double letter. So now it's saying the reverse thing, that it should not end in a double A or double B, right? So how we can ensure that if it does not have to end in a double letter, that means we can place either AB or BA in the end, right? So now it is ensured that it is not ending in a double letter. But we have some strings that are being left and are not formed from this regular expression, but are part of the language, right? Like if I have to form a single A is belonging to my language, it is not ending in a double letter. Single B is belonging to my language, it is not ending in a double letter. Lambda is also belonging to my language, but it is not part being formed from this regular expression. So we can add these words which are left out by using the plus sign. Let's take another example. If it says, write a regular expression for all strings that have exactly one double letter. Now it says that, okay, double letter can be part of the language, but exactly one double letter has to be there, right? Either it can contain double A or it can contain double B. In any case, double A should not come from any part of the substring. So let's write for double A first. It's saying exactly one double A, right? One double letter we have encountered. Now, following this and after this, I cannot place BA here, right? Because if I place BA here or any substring that can be formed from BA regular expression, then again this double letter is being formed and this double letter is being formed, which is not allowed. Only one double letter has to be there. So I cannot place BA substring over here. So I have to remove this. Let's remove this. Double A is there. But I can place AB here, right? AB is not ensuring that double A is being formed. And obviously it can repeat any number of times, right? Similarly, but here I cannot place AB because here if I place AB, again this double A comes together. So here I have to do the reverse. I have to place BA. I have to place a BA here. I place a BA. Again it can repeat any number of times. Now what are being left from here is, this is ensuring if I have to form a string like this, B, AB, AA, B. If I have to form this string, now will I be able to form this string from this regular expression? No. And will this language part of the language? Yes, it is part of the language because it is containing exactly one double letter. So to ensure that my string can start with B also and end with B also, I have to ensure that I can place lambda plus B here and lambda plus B here also. Now this lambda ensures that you have the option to make your string start with B, or your string can start with A also if you take a lambda from here. And here also it guarantees that your string can end with B also, or it can end with A also if you take the lambda from here. So this regular expression guarantees that double A comes once only. For double B, we just have to reverse the positions. Double B here. Now in front of this I cannot place AB because then BB will come together. I have to place BA here. Here I cannot place BA because then again BB will come together. I have to place AB here. To make my string starting from A, I have to place lambda plus A here. To make my strings ending with an A, I have to place lambda plus A here. So my entire regular expression becomes double A, AB star, BA star, lambda plus B, lambda plus B, BB, BA star, AB star, lambda plus A, lambda plus A. Let's take one more example which says, all strings in which total number of A's is divisible by 3. Now there is no restriction whether the A's should come together or they should contain in double. It only says that the count of the A's in your string should be divisible by 3, right? Like 3, 6, 9 or 0 also, and so on. So how we can make sure A, any number of B's can be there, obviously, no restriction on B's. Any number of B's, then again A, any number of B's, then again A, any number of B's. I've got 3 A's, 1, 2, 3. Now I can place a star over it. So star guarantees that 0 A's can be there also, and then followed by 3, 6, 9, 12 or any number of A's that are divisible by 3. So this is my regular expression for this particular language. So this was all about the regular expressions. In the upcoming video, we'll begin with the next topic, that's finite automata. If you like this video, then do like and share my video and subscribe my channel. Thank you.